Like he has the Rowdy Season Instagram.
Yeah, I met him at.
All right, so we're getting started now.
And like.
So we're going to be solving logarithmic inequalities today. It is an inequality that involves logarithms. So the following property can be used to solve logarithmic inequalities. So if b is greater than 1 and x is greater than 0, then log base b of x is greater than y, then x is greater than b to the y power. We do have to be careful with our domain in these types of problems. So our b value, that's our base right here. It has to be greater than 1. It can't be negative. It can't be a fraction. Okay, your x value here has to be greater than 0. Okay, so it can't be negative and it can't be 0. So we do have to be careful as we solve these problems. So in example 1, we want to solve log base 3 of x is greater than 4. So just like before, first thing we want to do is change this to an exponential expression. Okay, so it's a little bit easier for us to solve. So we will bring in base 3 to both sides, since our base in that log is 3. Okay, those cancel. You're left with x is greater than 3 to the 4th power. Okay, 3 to the 4th power is 81. So my answer for x will be greater than 81. That's it. Well, for this one. All right, then do number 2.
Cancel the 4.
Okay, write it down. Do number 2.
Oh. Okay.
Yeah, do your note sheet. Do number 2. Yeah. Okay, so in number 2, you want to bring in base 4 since you have a log base 4, so that cancels out. And you're left with x is greater than or equal to 4 to the 3rd power. Okay, 4 to the 3rd power is 64. So we have x greater than or equal to 64. Okay, so those two are very similar problems. Now with inequalities, you do have to be careful. So for 1 and 2, I want you to notice that your inequality is a greater than. That means it's going to continue to positive infinity, right? So example 3 is a little bit different. This time your inequality symbol is a less than symbol. Okay, so I'm still going to kind of solve it the same. So since I have log base 2, I'm going to bring in base 2 to both sides so that I cancel out my log base 2 in that base 2. So I have x less than 2 to the 4th power. Okay, 2 to the 4th power is 16. So we have x less than 16. Now up above in that chart, it says that your x value has to be greater than 0 as your domain. If I were to plot this on a number line, okay, I have 16 here, right? And this is saying that all my x values are less than 16. That means it's going to go to the left. Well, my domain for a logarithm has to be greater than 0. Okay, so that means I need all the values greater than 0. Okay, so I'm going to have a cutoff for my domain. So if you ever see that x is less than something, when you're starting off with a logarithm, you need to make sure that x is also greater than 0. Okay? And again, this is because the domain must be greater than 0. Okay, so that domain has to be greater than 0. So since I ended with x less than 16, that means all the values to the left of it, that would include those negative values, but that x cannot be in those negative values. So we have to say it also has to be greater than 0 within our answer. Okay, questions on why I did that to number 3? Okay. Looking. Yeah. All right, looking at the back then, the following property can be used to solve logarithmic inequalities that have logarithms with the same base on each side. Exclude from your solution set values that would result in taking the logarithm of a number less than or equal to 0 in the original inequality. So we do have to check our domain for these problems. So just like yesterday when I said after you solved for x, when we were solving equations instead of inequalities, you had to check both solutions to make sure they worked. Okay, in some cases they didn't both work. In this one, when you have an inequality, you have to check the domain. Okay, so whatever's inside your parentheses here has to be greater than 0. Okay, so whatever's inside those parentheses has to be greater than 0. So number 4, first thing I want to do is solve this inequality. Now, just like yesterday, if you have the same log base on both sides, okay, those are just going to cancel each other out because I could bring in base 4 to both sides and they'll cancel. So I can set x plus 3 greater than 2x plus 1. Okay, so same thing as yesterday except you have this inequality symbol now. From here I'm just going to solve for x. Okay, so I'm going to subtract x from both sides. So we have 3 is greater than x plus 1. Subtract 1. So we have 2 is greater than x, which is the same thing as x is less than 2. All right, so after we find that x is less than 2 value, we need to check our domain. So I'm going to take what I have in my parentheses here for both logarithms, and I have to set those greater than 0. Okay, so x plus 3 has to be greater than 0, okay, because it cannot be negative or 0, and so does 2x plus 1. Okay, so both of those values in parentheses, they have to be greater than 0. From here, I can solve for x in both cases, so subtract 3. So x has to be greater than negative 3. Here, subtract 1. I have 2x is greater than negative 1. Divide by 2. And x is greater than negative 1/2. Okay, so now I have these 3 different values. Okay, I'm going to plot these on a number line. Okay, so I have a negative 3, I have a negative 1/2, and I have a positive 2. Okay, so with this positive 2 value, all of my x values have to be less than that value. Okay, so I have an open circle at positive 2, and all of my x values have to be less than that, so they're going to go to the left. Okay? For x greater than negative 3, okay, I have an open circle at negative 3, and all of my x values have to be greater than that negative 3, so that's going to go to the right. Then the last one, negative 1/2. Okay, again, open circle at negative 1/2, and all my x values have to be greater than that. Okay, now when I do this, I want to see where all 3 of those overlap. Okay, where there's that shaded in line for all 3. Okay, so that would be between this negative 1/2 and this positive 2. Okay, all 3 of those have that shaded part between those 2 numbers. So that means my final answer for this problem will be x has to be greater than negative 1/2 and less than 2. Okay, so x has to be greater than negative 1/2 and less than 2. So it has to be between those 2 numbers. Okay, questions on example 4. Okay, you do need to plot these on the number line. It will help you determine your final answer. Okay, so each of those parentheses has to be set greater than 0. Okay, so each of those parentheses greater than 0 to check that domain. Plot them on the number line. Shade in where it tells you to. All right, then going through number 5, we're going to do the same process. So since both of these are log base 5, okay, we can cancel those out. So we end up with 2x plus 1 is less than or equal to x plus 4. Okay, from here we just continue solving for x, so subtract x from both sides. So I have x plus 1 is less than or equal to 4. Subtract 1. So here I'll have x is less than or equal to 3. Okay, my next step is to check the domain. So I need to take each of the values in those parentheses and set them greater than 0. Okay, so 2x plus 1, that first one there has to be greater than 0. And that second one right there, x plus 4, also has to be greater than 0. Okay, solve for x in both cases here. So subtract 1, get 2x is greater than negative 1, divide by 2, and x is greater than negative 1/2. Here, subtract 4, so x is greater than negative 4. What's my next step? After I find all 3 of these values. Plot them on the number line. Okay, so I have a negative 4, I have a negative 1/2, and I have a positive 3. Okay, so over here, my x value has to be less than or equal to 3. So I have a closed circle on 3, and all my values have to be less than that value. So that's going to go to the left. Okay, so there's my first one. My next one, my x values have to be greater than negative 1/2. So I have an open circle at negative 1/2. And all my x values have to be greater than that one, so to the right. Last one is at negative 4. Okay, again, open circle. And again, those values have to be greater than that -4, so that's going to be shaded to the right. Okay, we want to look where all three overlap. Okay, that would be at -1/2 and then ending at 3. Okay, so between these two values here, so that'll be my final answer. So x has to be greater than -1/2 and less than or equal to 3. And yes, it's less than or equal to because that's what I ended with here. Okay, questions on example 5. Okay, it was the same process as example 4. Okay, so first solve for that x value in the original equation, set both parentheses greater than 0 to check that domain, plot it on the number line to get your final answer. All right, then last problem here. Can anybody tell me what's wrong with example 6 before I even solve the problem? Okay, it has an equal sign, which is different than what we were just doing. What else? No. You can have an x squared. This is a problem like we did yesterday. Okay. What do you know about the values in your parentheses when we were checking afterwards?
Negative.
There's a negative right here.
Dang.
Okay, so I have a log base 6 of -8. If you were to plug that into your calculator, not that you can on yours because you can only do log base 10. Okay, if you were to plug that in on your calculator, it would say error. Okay? If that happens, so if you ever see this, okay, right away, off the bat, before you even try and solve it, this would be no solution.
Because of the negative?
Yes. Okay, because you can solve it, you can get answers. So I got an answer of 4 and 2, and I was going to show you that and then tell you it was no solution afterwards, but figured you'd probably just want to know it was no solution. So I got an answer of 4 and 2. I plugged them in to check, and neither of them worked because you're always going to end up with this -8 here. But it already started as -8. So since it started with a domain error, it's going to end with a domain error. Okay, so that's why it's no solution. Okay, so if you ever see a problem like that, a log base anything of a negative number, it's no solution right away. Make sense? Yeah?